What up, people? You guys ready to learn more about reactions with alcohols? Today, we're going to be looking at the acidity of alcohols. That is, why alcohols can behave like acids sometimes. No, I said like acids, not like ass. Not like jerks. Anyway, keep watching and we'll show you what we mean. Okay, so yeah, alcohols really do behave like acids sometimes. That is, they share certain interesting properties with acids, which is why they're so reactive when it comes to making what are called alkoxides, which is our topic for today. But let's start with the basics. Why would alcohols want to be acids anyway? Actually, alcohols aren't really all that good at being acids, but what they are is polar, and that's because of their OH group. See, the oxygen atom is electronegative and the hydrogen is electropositive. This creates partial charges and polarity. So now if we take a really strong base and react it with the alcohol, it drops the H, and that means that an alcohol is a weak acid. If you didn't really follow that, that's okay. Just go ahead and check out our playlist on acids and bases. Now when an alcohol loses an H, it becomes an alkoxide. That is, an alkoxide is the conjugate base of an alcohol. As for what these things can do, we'll tell you in a bit. But for now, just know that alkoxides can be really useful. Basically, there are two different ways to turn alcohols into alkoxides. The first way is to react an alcohol with a base. To do this, what you need is a base that's stronger than an alkoxide, like potassium hydride, for example. So let's go ahead and react potassium hydride with an alcohol, say methanol. The potassium hydride splits up into a potassium ion and a hydride ion. The hydride then goes after the hydrogen atom in the menthol's hydroxyl group, which has a partial positive charge. This produces elemental hydrogen, H2, and the methanol becomes methoxide. The potassium ion stabilizes the methoxide electrostatically. There's not much more than that. So the first way to produce alkoxides is to react alcohols with very strong bases. Now the second way is to react alcohols with alkali metals. We'll show you what we mean by reacting ethanol with sodium. We're going to need 2 ethanol molecules and 2 sodium atoms. And this time we're dealing with a redox reaction. The sodium gets oxidized, and the ethanol gets reduced, releasing 2 hydrogen atoms as hydrogen gas. So the products are ethoxide, sodium ions, and hydrogen gas. And in this case, the alkoxide is also stabilized by the alkali metal. So the second way is to react alcohols with alkali metals. Alright, so what can we do with these alkoxide things? I mean, yeah, the reactions are pretty cool and all, but what then? It's simple actually. We can use alkoxides to make ethers. And ethers are super important in the chemical industry and in research. Their ambivalent characteristics make them ideal solvents. The simplest way to synthesize ethers is called Williamson ether synthesis, which we talked about in another video. Okay, here's everything on one slide. Alcohols are weak acids. They get deprotonated to become alkoxides. This is done by reacting them with either strong bases or alkali metals. Alkoxides are used to produce ethers. If you want to learn about other chemical reactions involving alcohols, just keep clicking through our playlist. Have fun!